is the Earth? A few centuries ago, people had no idea of the age of the Earth. Scientists relied on theologians and believed that the Earth had been around as long as the human race and leaned towards the figure of 4,000 years. It was only about 200 years ago that scientific research began. By carefully studying the timing of geologic processes such as weathering or erosion and the thickness and location of rock layers of the Earth's outer shell, scientists pushed the origin of our planet back to an unimaginably distant time, more than 4.5 billion years ago. The easiest and most accessible rocks to study are sedimentary rocks, layers formed by the precipitation of mineral particles from air or water. Look at a layer of dust and imagine how long it takes for something substantial to form. Back in 1669, Danish naturalist Niels Steno formulated the law of superposition. In a sequence of sedimentary strata, the layer below formed before the layer above. That is, young layers are at the top, and older rocks lie beneath them, and the further away they are, the older they are. In the 19th century, a period as a unit of geologic time was allocated for the first time. However, geologists did even have an approximate idea about the duration of periods. Each period was defined on the basis of rock complexes. In determining the age of certain periods, characteristic fossils, called guide fossils, were identified. The mass extinction of some animal species and the appearance of others made it possible to establish boundaries between geological periods. Another feature that helped the first creators of the time scale was the nature of the rocks themselves. Thus, the Cretaceous period was singled out as the unit covering the most powerful deposits of the writing Cretaceous. Stratigraphy is a technique that has helped to read the Earth's history, recorded in its ever-changing landscapes. By studying the sequence of layers, geologists have determined what the planet's climate was like at the relevant epoch, and what animals and plants lived there. In 200 years, scientists have well studied about 600 million years of the epochs that preceded us, but what came before remains largely a mystery. But, of course, it is well known now that contrary to the law of superposition, for some reasons older layers can overlap younger ones. During the movement of lithospheric plates and due to the processes of mountain formation, strata can be overturned. Fluid volcanic rocks can intrude into ancient sedimentary and rock layers. After cooling, a young volcanic layer may solidify between two older ones. There is also a special type of cross-layering, angular heterogeneity. This phenomenon occurs when no sediments are formed in a given area. Then, during various geological processes, the surface of the area where layers have ceased to form moves and is covered by older layers. When sedimentation resumes, the new layers overlap the older surface at a certain angle. This process can last for many millions of years. Such fossils as devil's fingers, belemnites, ammonites, etc., were widely known for many centuries. But only by the end of the 18th century. Scientists agreed that these are fossilized remains of living creatures, ancient and often extinct. In the early 19th century, three scientists at once, Georges Cuvier, Alexander Bognard, and William Smith, discovered that successive layers of sedimentary rock contain fossils characteristic of a particular geological period. This at first glance not so complicated conclusion played a very important role. It became possible to establish the order of sedimentary succession from the guide fossils. A variety of sediments still form on the bottom of water basins. Near the shore, the sediments consist of large stone fragments, while further away from the shore they are increasingly finer muddy and calcareous sediments. When a dead mollusk, for example, sinks to the sea floor, its soft tissues decompose and the shell is filled with sediment as a mold for casting. Over time, the shell becomes fossilized or dissolves, but the casting remains. When land animals die on the surface of the earth, they decompose almost completely and very quickly. But if they fell into a frozen swamp or into the silt at the bottom of a cave, the skeleton and often the whole body fossilized. Many animals have died in volcanic eruptions, floods, sandstorms. Photographs from which the history of the Earth is read are places where rocks are exposed, such as quarries, mines, and geologic wells. By comparing individual sequences of stratigraphic layers, the entire history of the Earth began to emerge. The first attempts to determine the age of the Earth by stratigraphic methods were made in the middle of the 19th century. Englishman Charles Lyell came to the conclusion that the age of the Earth is 100 million years. Charles Darwin estimated the duration of the Tertiary period in 300 million years, in fact, only 65 million, and his theory was built without taking into account the chronology of fossil remains. The most accurate results, which are still considered relevant, were obtained later, when Claire Patterson in collaboration with George Tilton in 1948 began to develop new methods of radioisotope dating, uranium lead and lead-lead methods. A few years later, they managed to take samples of the Canyon Diablo meteorite, due to which scientists got the most accurate age of the Earth, 4.5 billion years. That's how we managed to find out the age of the Earth. Thank you for watching this video. Put a like and subscribe to our channel. Bye.